Ninth question says that without using distance formula, show that the points this are the vertices of a parallelogram. Okay. So if we wanted to use the distance formula, what you would have observed is this: A, B, C and D. If this is the case, then you could have observed that AB and CD will be equal, something of that sort, and BC and AD would be equal, something of that sort, and the diagonals will not be equal for a parallelogram. If the diagonals also become equal, then it becomes a rectangle actually, right? Parallelogram, a rectangle is a special case of parallelogram, and alternatively, right, you can also guess that. But no, we are not supposed to use that. We are supposed to discuss using some other approach, right? What is that? Without using the distance formula, show that the points that this is. For a parallelogram, by the way, one very easy approach is using the section formula, right? And always, whenever you get a parallelogram, think of that approach. Here, we'll not use that approach, mind you, but always think of that approach. We'll solve this question using slope as well, right? So, but one of the approaches is that for a parallelogram, the only sufficient condition, necessary and sufficient, is diagonals bisect each other. For any quadrilateral, if the diagonals bisect each other, then you can say that it is a parallelogram, for sure, 100% sure, right? This is a simple approach. Another approach that we can follow is that m of AB, slope of this side will be equal to m of CD. Slopes of opposite sides are equal. They are basically, the lines will become parallel. The opposite sides are become parallel, right? And that's the property of parallelogram, right? That the opposite sides are parallel. This slope is equal to this slope, and m of AD is equal to m of BC. Both of these should be correct. That's another way of proving that the given figure is a parallelogram. That's another approach. So which of these will be we using? This one is pretty simple. You can always follow this approach. Let's mark the points on the Cartesian plane first of all. We have -2, -1. -2, -1 is somewhere here. Okay. We have 4, 0, which is somewhere here. 4, 0. Then you have 3, 3, which is somewhere here. And you have -3, 2, which is somewhere here. Okay. So vertices are given A, B, C and D. Okay, this becomes AB, BC and AD. This is what you have. So the vertices are given in a particular order. Yes, they are given in the anti-clockwise order. That's a good thing, right? And if you can prove using the first one, it becomes very simple. What you do is you find the midpoint of AC and you find midpoint of BD. So midpoint of AC, okay. Midpoint of AC will be 3 minus, x1 minus x1 plus x2 by 2. 3 minus 2 by 2 is 1 by 2, okay. And this 3 minus 1, which is 2 by 2, which is 1. This is the midpoint of AC, using idea of midpoint. What is the midpoint of BC? BD. For BD, you have 4 minus 3, which becomes 1 by 2, x1 plus x2 by 2. And you have 2 plus 0 by 2, which is once again 1. Since the midpoints are exactly same, since the diagonals bisect each other, therefore you can say, yes, the given figure is a parallelogram using this idea. But then, NCERT people are lovely people. They want you to solve using this idea. They've taught you slope, right? Using this idea, you have already discussed parallelograms in the previous classes, but then this is the idea which has been discussed. Now, let's solve using the idea of slope. Okay, let's try to find the slope of AB. Let's try to find the slope of BC, m of AD and m of CD as well, right? So m of AB will be 0 minus of -1, which will become 0 plus 1 upon 4 minus of -2, which becomes 4 plus 2. This is 1 upon 6. What are you doing? You are doing y2 minus y1 upon x2 minus x1. What about slope of BC? You have 3 minus 0, y2 minus y1 upon 3 minus 4, which is 3 upon -1, which is -3. What about slope of AD? AD, you have 2 plus 1 upon -3 plus 2. y2 minus y1, this is 2 minus of -1, which will become 2 plus 1, and x2 minus x1, which is minus 3 minus or minus 2, that becomes minus 3 plus 2. This is 3 upon minus 1, which is minus 3. Pretty interesting. M of CD is y2 minus y1, 3 minus 2 upon 3 plus 3. y2 minus y1 upon x2 minus x1. This is 1 upon 6. Okay, can you observe that these two slopes are equal and these two slopes are also equal? Since m of BC is equal to m of AD and m of AB is equal to m of CD, this implies that the given figure is a parallelogram. The given figure is a parallelogram. That's what you have. That's what you can observe, and that's a complete proof of this question over here using this idea of slope. Right. That's a complete solution of this question.